Hello friends, welcome to Legend Lens, and today we look at a very important topic in applied electricity, that is current division. Now, whenever current approaches a node, it splits into two or more currents, and that is basically dependent on the nature of connection at the node. And so when you consider this circuit, I is the total current, and then when it reaches this node, this is node A, it splits into two, becoming I1 and I2. And so in order to find this value, that is I1 and I2, then we can use the current division law to find it. So let's see how we do that. Now we can clearly see that these two resistors are connected in parallel, and so the total resistance is simply R1 parallel to R2, which becomes R1 R2 all out of R1 plus R2. We also know from Ohm's law that our V is equal to IR, in this case the total resistance, and so it becomes V being equal to I multiplying our total resistance, which is R1 R2 all out of R1 plus R2. Now, since the resistors R1 and R2 are in parallel, then the voltage across each of them is the same, or are the same. The voltage across them are the same, and so the current through each of the resistors will simply be given by the supply voltage divided by the resistance, and so I1 becomes V divided R1, then I2 also becomes V out of R2. V here we are saying is equal to R1 R2 all out of R1 plus R2. So I1 becomes V which is R1 R1 plus R2 multiplying I, all divided by R1. And then when you solve this, you get I1 to be equal to I R2 all out of R1 plus R2. So we can rearrange this as I1 being equal to R2 out of R1 plus R2 multiplying I. Similarly, when you do that for I2, you get R1 out of R1 plus R2 all out of R2, and this turns out to be I2 being equal to R1 over R1 plus R2 multiplying I. And so now from the two formulas that you've obtained, that is this and then that, we can clearly note or see that the current in a particular resistance, say R1, in this case we are finding I1, so the current through I1 is obtained by multiplying the total current, that is I, by the other parallel resistance, in this case becomes R2, and dividing by the sum of the two resistors. So looking at this formula, I1 is equal to R2, that is the other resistance in parallel with R1, divided by the sum of the two resistors, then multiplying it by the total current, that is I. Similarly, the current through R2, that is I2, is also found by multiplying the total current I by the other resistance, that is I1, and then dividing by the sum of the two resistors. As simple as that. Now with this I1 and I2, we had all the current values being positive. That is because they are all flowing in the same direction as the supplied current. But then when you look at this circuit, we can see that I2 is flowing in a direction opposite to that of the supplied current, and so its value becomes negative, and so I2 now turns out to be negative R1 plus R2 multiplying I. It is much important to check the arrows always before solving. Alright, so let's take the example and see. So we have this circuit here, we have to find the values of I1 and I2. So simply use current division to find our current. So I1 becomes R1 plus R2 multiplying I, which turns out to be R2 in this case is 2, lot of 2 plus 3 multiplying 10, and this becomes 4 ampere. Now I2, the direction is in opposite to that of the supplied current, and so it becomes negative R1 out of R1 plus R2 multiplying I, and this becomes 3, 2 plus 3 multiplying 10, which becomes negative 6. So that is all about current division. That's simple. Thank you very much for watching. Subscribe for more of these videos. Thank you.